Very much for joining me today. So my name is Marcin Szydłowski. I'm going to speak about insecure HTTP headers. So in general, this topic is about web application security, but not only web application security. So we'll just jump to this topic a little bit and discuss a couple of things. So yeah, that's the table of contents. So we are going to speak about two types of headers. First of which will be host header, and second of which will be X-forwarded for header. So I would like to explain what are the risks associated with these two headers and how can you deal with them later on. So who am I? So as you already mentioned, my name is Marcin Szydłowski. I'm based in Krakow, Poland. So I used to work as a pen tester, like full-time pen tester. I used to work for some global banks, global financial companies. Right now, I work as a security consultant for one of the global companies as well. Apart from that, I'm a security researcher and a bug bounty hunter. I do mostly private bug bounties, but sometimes I'll participate also in the public ones. So in general, that's it. Why HTTP headers? Because, as I mentioned, I do a lot of bug bounty programs. And the thing is that these, let's say, most common vulnerabilities like XSS or SQL injection, some, I don't know, insecure direct object reference, it's very hard to find these vulnerabilities in bug bounty programs because, a lot of people test these sites, so it's not that easy to find common vulnerabilities. So these vulnerabilities are not a common one. The thing is that they are not described in OWASP Top 10, which is probably the most well-known document about vulnerabilities in the applications. They are not described in OWASP testing guide, so I checked that before coming here. And basically, if you go to OWASP methodology, there is nothing about HTTP headers, about these two that I'm going to present you today. So the thing is that not a lot of people know about these vulnerabilities. However, they result in high impact vulnerabilities and high risks for the entire organization. So we'll go through some examples today, but basically, as I already mentioned, they're very uncommon. They are hard to find because they are not easily detectable with automatic scanners. They are infrastructure or architecture dependent. So basically, they might be in one application on one environment, but not in the same application on the other environment. So because of that, I believe that they are not that popular among speakers and researchers. So hopefully this will be something new for you as well. Okay, so basics. So what are HTTP headers? So each time you perform some actions, let's say in your web browser, your web browser will send so-called HTTP request to the web server, and this request contains of HTTP headers, which are these, and from a request body, which is sent right after HTTP headers. So basically, as you can see here, you have like a couple of them. So host, user agent, cookie, connection, all of these. Basically, if you Google that in Wikipedia, you will find a list of 51 common HTTP headers. So as I already mentioned, today we are going to discuss two of them. So first of all, the host header, which basically allows you to differentiate to which host, to which virtual host the request should go to. So for example, if you have a number of applications residing on the same host, you can choose which of them should this request reach. And the second type of header is X-forwarded for. So this is a header which is used by proxies, by load balancer, to tell our server what's the real IP of the client. I set it up AWS Lab. So if some of you prefer to test that on their laptops, you can just go to this web page and play it with that a little bit. It's not like super fancy environment, but in general, some of these examples that I'm going to present today might be just check on this website and you can easily see what are the results. This URL will just go all the way down here, so it will be presented here during the entire presentation. Okay, before I start, do we have any penetration testers in the room? Okay, cool. And do we have any developers or DevOps? Okay, great. So starting from the first issue, so poisoning. So poisoning is, I would say, it's quite common because a lot of people know about host poisoning. But the thing is that it's hard to find a practical example of exploiting this vulnerability. So in general, these attacks are described on the internet, but it's hard to find like a use case of such an attack. However, the example that I'm going to present will give you such an opportunity. So this is a common password reset flow. So user wants to reset his or her password. He will send a request to some web server like ebanking.com with his email in post request body, and server will respond with an email which allows him to set a new password and to reset the old one, right? So the thing is that if the application is vulnerable to this host header poisoning, a hacker or a bad guy basically can use host header with some, let's say, malicious website, send this request to the web server, and if the application is vulnerable, the server will respond with an email with this malicious domain within its body. So basically, server will take this value and just paste it to the email. So the email will come from the legitimate mail server. However, the link will point user to some malicious site, right? And in that case, if user is unaware of what may happen, his credentials will be sent to the malicious attacker. Another example, also connected to host header. This is not directly related to web application itself. It's more like infrastructure. However, it's also like quite a crucial one. So let's imagine a situation where we have two servers, which are, for example, behind some load balancer, or you can also consider that as two virtual servers on one physical host, for example. So in that case, when user wants to reach external one ebanking.com, he will send the request will be intercepted by some proxy or load balancer, and the load balancer will send that request to this server, right? The thing is, and then the server obviously will return some web page, right? The thing is that an attacker may simply modify value of host header, and if web proxy is not configured properly, or if someone decides to host internal and external applications on the same host, there is a chance that this request will get forwarded to some internal web server, and internal web page will be returned back to the attacker. So basically, we can get an access to the internal infrastructure just by abusing the host header value. Now, if you think that such an attack is uncommon, you can just go to these two articles later on, or just try to Google that. So basically, one guy from, I believe, Ecuador found such a vulnerability in Google, so he received like $10,000 bug bounty. There was some other guy who also used this technique to basically infiltrate like 27 Department of Defense servers. So it's a pretty, let's say, huge issue in the end. So just to sum up this, let's say, this first chapter about these host header issues. So obviously, you need to remember that all of the data which is passed in HTTP headers might be spoofed by the attacker. So you shouldn't trust any value which is passed in the host headers or any other headers. What's very important is that these vulnerabilities are not specific for tested services, because in the end they may also result in abusing some, for example, internal services and in some other applications, right? So some other let's call it applications residing on the same host. So the thing is that, for example, if you are able to exploit this vulnerability that I mentioned on the previous slide, you are able to get access to some other applications and not only to the tested one. Okay, so these are, let's say, tactical recommendations for the developers. So you shouldn't trust any values which are passed in the host header and in X-forwarded host header, because in general, if you're not able to exploit this vulnerability using host header, you should probably add additional header which will be X-forwarded host, and there is a strong chance that one of these headers will work just fine with this application. You need to watch out while deploying solution on multiple environments. So that's a quite common issue that, let's say, lazy developer will just take his application, implement it on its own, let's say, testing infrastructure. The application works just fine because it just takes the host header value and pastes that in the email. However, later on, when this application is deployed in client environment, it's vulnerable to this issue, which allows to send a spoofed password reset emails. So because of that, you need to remember again not to trust the host header. And obviously, probably the most important one, but not specific for web applications. So make sure that you configure your reverse proxy and virtual hosting correctly. Obviously, it's probably easy to say, not easy to do, but in general, you should probably avoid, for example, hosting external and internal applications on the same host. Okay, second header, which I would like to discuss today, is X-forwarded for header. So again, that's a header which is sent by a web proxy tool to the web server for web server to understand what's the IP address of client. So that's the legitimate flow. So let's imagine that we have some application which allows an administrator to view the access log in the web browser. So clients coming from 9876 IP address wants to reach ebanking.com. He sends a request. This request is intercepted by some proxy or load balancer or whatever. So this device puts X-forwarded for header with IP address of this customer, and it sends that to the ebanking.com, right? So now the ebanking.com server knows that there is this device in between. So it will take the IP address from this header and put that directly into access log on the server. So basically, it should work just fine, but there are many issues with that. So first of all, different applications treats values in that server, in that header, in a different way. So some of the applications, if they see, for example, multiple X-forwarded for values, they will take only the first one. Some of them will take none of them. And you need to remember that sometimes there might be a situation when someone decides to change the architecture, the network architecture, and basically they will decide to take that piece, take that device out of the, let's say, our application architecture. And in that case, anytime that an attacker will send a request with X-forwarded for header, he will be able to spoof the IP address of all the requests. The thing is that he can use this technique, for example, to inject the cross-site scripting value. So I spotted this vulnerability like number of times in couple of, let's say, of some major banks during bug bounty programs. So I would say that this one is common one. It's not always, you are not always able to paste to embed the XSS payload. However, spoofing the IP address of incoming request is quite an obvious thing. Okay, more issues related to X-forwarded for business logic bypass. So, for example, if you have some web page which allows you to vote I don't know, for whatever, right? So there might be some voting page, and the person who gets the most votes wins some competition, wins some prize. So in that case, again, if the application is not configured properly, it is possible to send multiple requests with coming from different IP address. And despite the fact that this application is configured to allow only one vote per IP, we are able to bypass this let's say, mechanism by using multiple X forwarded for header values. So again, I just calculated it really quickly. So basically, you can add yourself like 4.2 billion of votes. And again, that's a vulnerability which I identified during one of the bug bounty programs. So again, it's not a common one, but it will allow you to like impact the results of the voting pretty much. And the third scenario, also related to X forwarded for header, that's an issue which I have not identified personally, but my colleague identified that in one of the global banks again. So access control bypass. So as you probably know, some of the applications rely on the IP address if they want to restrict the access to some resources on the web server. So basically, by simply modifying the value of X forwarded for header, you can basically access, for example, admin resources or some other restricted resources. So basically, my colleague used that technique to get access to some debug web page, which later on allowed him to perform remote code execution on the web server. So that was just the first step. So he just put the local host in X forwarded for header, and it worked just perfectly. Okay, so the question is how to avoid that. So the problem with this is that this is like strictly dependent on the infrastructure and of the architecture of your web application. So even if you're a developer and you do a great job or a good job, it may happen that you will be vulnerable to this kind of attacks because people from your infrastructure team removed something from some component from the system and never told you about that. So there is such a risk. However, we can somehow mitigate such a risk. So first of all, we can create the applications which, let's say, are aware of such a possibility, and then you can adjust your code to prevent such an attack. Obviously, you shouldn't trust the values which are passed in the X forwarded for headers. And you should encode all the values to avoid these cross-site scripting attacks. Last but not least, probably the most important one. So think twice before copying and pasting code, because you may encounter some of the code snippets, for example, on, I don't know, like on Pastebin or Stack Overflow or wherever else. So these code snippets may work just fine on their environment, but on your environment, this one is going to work like completely different and may cause some issues. Okay, so summary and key takeaways from the presentation. So as I already mentioned, so most of these examples were identified in live systems which were exposed to the internet. So basically, you could easily exploit that vulnerabilities to get control over some server. You could exploit that to spoof some emails. You could exploit that to modify the results of some online voting, right? As I mentioned a couple of times, it's really important to remember that these vulnerabilities are strongly dependent on the used infrastructure and architecture. So it's not very easy to detect that. What's even more important is that we have more and more vulnerabilities which are directly related to the underlying infrastructure. So for example, cache poisoning, so that's one of them. Edge site includes, so that's a vulnerability which basically is dependent on the caching servers, which might be before the application. And also more and more people implement TLS 1.3, which has this zero RTT. Let's call it a feature. However, if you enable that TLS 1.3 with zero RTT, you need to remember that you need to prevent or to fight the replay attacks on the application level. So again, the application which may work just fine on one infrastructure may work completely different on some other infrastructure. Okay, so strategic recommendations coming from that presentation. So first of all, increase security awareness among code developers and solution architects. So yeah, I think that's quite obvious, but what is quite important is that if you are able maybe to discuss all the changes with them and discuss potential impact, they will understand what are your concerns and they will somehow help you with that. So obviously you should review code snippets if you use some. So if you have like, I don't know, some code repository in your company, so maybe it would be good to review them for potential infrastructure related vulnerabilities. And if you find one, maybe it would be good to add some comments to this code in code repositories. For example, that this code works only if you have a web proxy if you have a proxy server between you and the client. Quite an obvious one. So if you run some let's say DevOps team, make it DevSecOps team. So you can identify all the vulnerabilities in the early stage of the project. Obviously, you should also perform a lot of manual security testing. Probably, it should be considered to perform them in the, let's say, let's call it final or ultimate environment. So for example, before launching something to prod, before launching the application, you should test that on the very same environment, and if the tests are successful, you should launch the application. It's quite easy to tell, quite easy to say, not that easy to do in corporate environments, but yeah, you should at least understand the limitations of your environment, and based on that, take any further decisions how you should proceed with testing. Okay, that's it from my side. So I hope that you enjoyed the presentation. If you have just any questions, just ask them now, or just drop me an email, and hopefully I will be able to answer them.